Hello everyone, it's November the 29th. Alright, let's do it. Account merge. Merge accounts. We've done this before. Oh, it's a new question. Alright. Given, oh my god. Given a list of accounts where each element is a list of strings where the first element is a name and the rest of the elements are emails representing emails of the account. Now we would like to merge these accounts. Two accounts definitely belong to the same person if there is some common email to both accounts. Note that even if two accounts have the same name, they may belong to different people, as they can have the same name. Yeah, a person can have any number of accounts initially, but all of their accounts definitely have the same name. That is true. After merging the accounts, return the accounts in the following format. The first element of each account is the name, and the rest of the elements are emails in sorted order. The accounts themselves can return in only order. Okay, so we have John with blah and blah, another John, Mary, and another John. So that means these two Johns are together because they have the same email address. So I'm going to return this with John00, John New York, and John Smith, and then John Johnny Bravo. The first and second Johns are the same person as they have a common email. Third John and Mary are different people. None of their email addresses are used. If we return these lists in any order, for example, example 2, we have Gabe, Kevin, Ethan, Hansel, and Fern. Well, none of these are the same person, right? So we simply just return these, as Ethan, Gabe, Hansel, Kevin, and Fern. We have a count of 1,000 accounts. Each account have length smaller than 10, and each is smaller than 30. Okay, it's a valid email. Okay, how shall we do this? I mean, we can turn everything into a set, and then we do set comparison between set. Doesn't seem to be a smart idea. All right, let's read again. So we merge. Two accounts belong to the same person if there is some common email to both accounts. All right. What if they have different names, but they have the same? That is a good question. What if this John and this John can be merged, but I don't call myself John, right? I want to call myself, let's say, Peter. What's this one gonna do? Like, they have different names, but they share the email account. People must have same name across accounts. Okay, so that will not happen, all right? So for two accounts to merge, they must have same name. Okay, so if they have different names, then they're different accounts. We don't have to worry about it. That's fine. So I have a John, right? And I can have this list, and then I have another John, and I have another list. Now, how do I know that the two Johns belong to the same person? Now, we're going to compare the email addresses. How do we compare the email addresses to know that this one? What if we say for each email address, we link to the name? That what should we call it? Let's say we have this email address will link to John, this email address will link to John, and the index of John. And then the next one, we have this email address. We have what? How many? 10. So it counts as 10. So it's 10,000. So for this one, I see if this email has been used. If it has, then I simply just append this to the end of this. All right? But also create a new one. This one. Oh, isn't that union fine? Union and fine. It would be tough to union fine, but basically we're saying everything will be grouped to the first one, right? So for this, for each one, we check if it's there, and if it is, right, then we simply for the rest, we'll be adding to this one. So this one will be expanding with whatever it has. We do have to turn this into a set. How about we turn that into a set? We turn this into a set, and we simply add everything into the set, right? And then for everything, also we have to do a hash map. So everything will hash to the name. You can actually hash to, not the name, but hash it to the index, right? So we're going to go through this one by one. And Mary. And what we do is we will create a new one. We'll create a new one where the first element is name. Second element is going to be a set. And as we created, everything will go to the hash map. Now the next one, right? And if it's nothing, we just add it to it. If there is something, we append. Okay. So Mary is nothing, so add to it. If John is nothing, we add to it. That might work, but it's gonna be taking a lot of space. But we're gonna give it a shot. Okay. Here it is. All right. So what do? We're gonna have a hash map, right? That is just going to be this, and we also have a result. It's going to be this. I'm going to say for. Well, for account, let's say for accounting accounts, all right? And the name equals ACC0, and we have to say if the email address, right? So for each email address, if it's not in there, if the email address is not in there, okay, this one has to be I, because I want to enumerate, right? So a name. We don't care about the name, right? We don't care about the name. What we care about is the email addresses. So what we're gonna say is we have to go through everything to see if it exists in the hash map. Okay. Okay, so we're gonna say for email in ACC 1 to the end, right? For this, we say if email is in hash map, then we break, right? Now we come out and have else. Else means none of the email is in a hash map. Then we simply do each email will go, or have to do it again, each email. So we're gonna say for email in this, right? We're gonna say hash map email will equal to I, right? So we put this inside, and then we're gonna say res dot append. Oh, the res needs to be this as well. So we say res I, right? Res I will equal to a set ACC1, right? So this is how it is, and we continue. Otherwise, if we break out, right? If we break out, that means for the current email is in hash map. But we need, okay, let's do this. Index, right, -1, right? If email in hash map, now we say index equals to hash map email, then we break, then we check. If index is smaller than 0, it equals -1, we do this, else we have the index. Now we have the index, so everything has to hash map to this index. So we say for email in this, right? So hash map email will equal to -1, not -1 equal to index. And then once this, and we say res index dot add email, right? And now we don't need continue. So can we do something so that they can be grouped together? Yes, we can. All we need to do is we say if index is equal to -1, right, which we don't find it, then we simply say hash map, not hash map, res I equals to an empty set. And then we say index equals I, right? Index equal to I. If index is this, index equal to I. So we can do this and everything will be the same, right? So this will be index. So we'll combine. Basically, it's say if nothing is found, right? If nothing is found, then we will create a new. Yeah, so nothing is found, which means the current email address belongs to a new person. So I say result new person index. Actually, we can do this, right? Index equals this, and then we say index, res index equals the empty set. And then for everything, we're going to hash map for the email to the index. So if this is not -1, then we have something already in the res. And then we have the index and hash map. So we just convert the same index and the res to this. And blah, blah, blah. Once we're done, we simply return this. I'm going to say for I email set in res.items. That's not res.item. It's not res, right? I'll use a different name for this. This will be merged, right? Be merged. So all the res, let's rename it to merged. So I is the index this. So what we need is this. First one is going to be accounts. I. That's the same index as we go through accounts. 0, that's the name. And we need a sorted email set. That shall work. Okay? Now this will work. I think this will work, but we do run the risk of this thing become too complicated. Not too complicated, too long. Right? Take too long, which is definitely possible. Well, we're gonna see if this will take too long. All right, and on output has to be sorted. Okay, so we have accounts. This is a count. Merge accounts. If sorted res equals to sorted answer. Well, we have fail. Okay. But before we do that, I want to just sort it first. Sort answer dot sort. Then do this. Okay, so let's comment out the second one. Just take a look at the first one. So answer is this. Result of John, ba, ba, ba. Okay, John, ba, and a Mary, ba. Oh. Destruct. There you go. Destruct. All right, let's hope it's not going to time out. I mean, the runtime is number of accounts and the number of emails. So 1,000 times 10, 10,000. I think it should be fine. Let's try. Come on. Wrong answer. Oh, shoot. Got a wrong answer. What is this? Output. It should be a single David. Huh. So I say there are 2 David, but they say there are only 1 David. All right, so David 0, David 1, David 3, 4, David 4, David 5, David 2, David 3, David 1, David 2, David 0. Ah, I think I know what you're playing with. What went wrong? Zero, 1, 2, 3, 4, 5. I say 0, 1, 2. It has David 2 here. This is union find. I think you should use union find. But why does this one doesn't work? Okay, so because they're not union together. I see. Yep. It's because we did 0, 1, right? And then the 3, 4. Those are 2 different Davids. And then when we do 4, 5, so these are merged together. And we do 2, 3. So 2, 3 merged together, but 0, 1 is still not. And we have 1, 2, right? 1, 2. 1, 2 is the last one to merge them together, merge the 2 things together. which means they need to merge. They need to merge in a 2, right? So every single one. So are you saying that we should not break here? Okay, let's say we don't break. Then we have 2 indices. All right, we have 2 indices. Then what? And those 2 indices, yeah, we'll have multiple indices, right? And all these indices needs to be merged together. Okay. So now what? We have multiple indices, and then that is union find, but we just kind of do union find like by hand. Indices equals this, right? So every time it's in, we simply say indices dot append, right? We're gonna append this, but don't break. So I come out, we say if not indices, if not indices, then index is this, we're gonna merge, and we don't have to do this, and we say merge I equals set. Right? If not indices, then we do this. Else, if we have indices, then all the indices needs to be merged together. Right? And all the indices needs to merge together. How do we do that? We simply say, we just keep the first index, we can merge the rest to it. We say for index in indices 1, right? And then for every single of that index, we need to merge into the previous one. How do we do? Well, we have to change. No. No, 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 no. Let me think. All those email addresses in the hash map, all their indices need to change. That is a ton of work. Now we need union find. We need union and find. I'm gonna pull out union find. I think we do need union find. I do think we need union find for this. Okay. So this is a union find. And we have a DSU. What's the range for union find? I honestly don't know the range, but we can say, let's say range is going to be 1,000 items, right? So LAN accounts, right? So we say DSU equals DSU LAN accounts. And then we do need a hash map because we have to check all the. Do we need a hash map? We do, because we need to know what each email address corresponding to which account and which index, right? So that's the hash map. And also we have merged, right? Merged. Well, we probably can. We need to do something about the merged. Well, we probably don't need merged because the DSU, we will do union and find, right? So every single account will be merged, okay? So we just need a hash map. We don't need merged. I think we don't need merged. We just need a hash map. Okay, let's just say we need a hash map. We probably don't need merged. But anyway, so we have this, enumerate, right? And we have indices. So we need to check the hash map to see what we have, right? And whenever an index we have, then what? Then we're gonna merge them. Okay? We're just gonna merge them. We merge the two, right? We merge the two. If email is in hash map, then we get the indices. Okay? And when come out, we check indices. If we have and if we don't have indices, right? If we don't have indices, that means we simply do not. We can just put all these hash map will be new. This index is by itself. Otherwise, all the indices will be merged. Right? All these indices will be merged. So these indices will be merged together. And we can do it here, right? For each index, that's the index. And this index will merge with I, right? This index will merge with I, blah, 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 merge, merge, merge. Once it comes out, we already merged, then we can find the parent of the I, right? And that's how we add its email address to the hash map. Okay, so we don't have to append, right? So all we need to do is, wait, do we need to append? No, we don't have to append, right? So all we need to do is, if email is in hash map, then we simply say dsu dot union, right? We're going to union union I and this. So these two will be union together, right? So we don't need this. And once everything is union, we simply go through and we simply go through all the email again. So once they're all union, we simply go through again and we say parent, right, equals dsu.find I, and we for each one will go for parent. Right, so they will all go for parent. And I don't have to change the index for everything else, even if they do change, because they all union together. Because the union will point them all to the same parent. So I'm going to do this, right? So there's no merged, so it's just going to be hash map, right? Now, how do we return? The return is different. So the hash map is used just for this purpose, right? To see if this is in the hash map, and then we can grab out the index or the parent, or whatever it is. We grab the parent or index, and then we're in a union. So once every union is done, we need to go look into dsu.parent, right? dsu.parent, and we go through the accounts. And for everything in the account, I'll take out, I'll see what your parent is. And if you have a parent, and let's just say for I in range len accounts, you simply say dsu.find I, so kind of compress, make sure everybody has the same parent. Okay, So now when that is done, right, when that is done, we can go inside. We can go inside and pick out the parent, right? Will the parent be the smaller one? I don't think so. Because if I union the two things, and they're different, right? And then the ranking, I will always put x with a higher ranking. So parent y or equals to x the parent. Which means, well, in our case, I think I should change this, right? Change the order. So this will guarantee that a small index will always be the parent. Okay? Because if the ranking, if the parent is not the same, and if the ranking is the same, we always say the y's parent will become x's parent, and x's ranking will go higher. So we always pick the higher ranking. Okay, so in this case, I can simply go, so we do this to find I, just to compress, and then we go again for I in range. Well, actually, this one I can just say for I account in enumerate accounts. Well, maybe these two can be combined. Maybe they can be combined. Let me try. Alright, so we find I to compress the I, and then we say the parent, right, equals DSU dot, we can just say parent equals DSU dot find I, right? And we need to have a result. The rest will equal to this, right? And what do we do? What we say is we can actually say we cannot append, right? We cannot append because it's related to parent. So the parent position will add me, right? Therefore, I need this and a set, right, for this in range, land, accounts. Actually, I can just say in account, it's fine. And then parent equals this, and we simply say res parent 0 will equal to ACC0, right? They'll all be the same name. And res parent 1 dot union. All right, we need union here. Does union A equals set 1, 2, 3, B equals set, let's say 3, 4, 5, A dot union B is a new thing. So we're gonna say this equals res parent 1 dot union AC set ACC1, right? And we'll blah blah blah, we're done. Then we're gonna return something, right? And for name, actually not for name, email set in res, right? If name right? If name, then we're gonna return name and sorted email set and deconstruct. Okay, let's try this one. There we go. This one passed. So we do have to use union find. All right, try this one. Oh, the run code doesn't work because the name is not the same. All right, try this. It works. Submit. Yep, it is union and find. So use union find, but it's kind of slow, right? It's kind of slow. So this is LeetCode 721. I tried to not use union find, but it didn't work out. Every time union find, I try to see if I can memorize this. Parent is the list of this, rank is this. If when the find x, and if x parent is not itself, then we just find x as parent, and then we compress the path, and then return this. Yeah, I understand path, fine. Union, we find the parents. If the parents are the same, then we return false. They are in the same union. If not, we check the parents, rank, and we find the one with a larger rank, and then we assign the other parent's parent, the grandparent, to the parent with a higher rank. If they are the same, I just arbitrarily choose one, and my choice is always assigned to x, right? So we say y will be x rank. Yeah, I know, but next time I try to write it myself, right? Don't always rely on copy and paste. So with union and find, we can union the indices, right? Indices of the accounts. The only thing remains, the only other issue is how to determine whether two accounts need to be unioned. This is achieved with a hash map where each email address is associated, points to an index. Thus, if a new account's email address is in the hash map, we know the new account can union with the index pointed to, right? Pointed to by the hash map. Yeah, so that's basically it. So we go through every single one, and we check every email. We say if email is init, then we union. Init, we union, blah, blah, blah. Once we're done, we find a parent, right? And we find the parent, and we go through each email again to put this email in the hash map again. So once we're done, we go for here. Right, we go for here, then we go for accounts, we find a parent, and we say the parent will we get the name, right? And then we also get the set of email addresses. So yeah, it's pretty straightforward, but let's see what type of solution can we get. DFS. Ooh, we can go DFS. Yeah, what's the runtime on this? Well, O M, what was it, N M log N. OMN log N. It's probably faster. OMN log M. It's the same. DSU. Yeah, I can use DSU. Yeah, DSU is long. All right, let's read. So David. Oh, we turned this into a graph. So David 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4. Okay, let's just see this. Henry. Okay, so everything is how do we merge these two together? And then we'll merge at this point. David will merge. Okay. For each account, add an edge between the first email and each of the other emails. Traverse over the accounts. For each account, check if the first email in the account was already visited. If so, check if the first email in the account was already visited. So we keep something to record which one has been visited. If so, then do not start a new DFS. Okay, otherwise perform DFS with this email as the source node. During DFS, store the traversed emails in an array, also mark all the emails as visited. After the traversal is over, sort the emails and add to the account name and start at the start of the vector. Store the answer list. Okay, so we first do this. Each email is connected to everybody else, and then next one comes out, each email is connected to everybody else. So instead of creating a complete subgraph for each account, you can create a acyclic graph using only k-1 edges. After connecting an email to the second account, that email will have one edge going to an email in the first account. Okay, so for each account, I create this graph. The next we see if the first email has been visited, that means everything in this can be merged. How do we merge the two? We simply merge the two, all right? We add this two, okay? Otherwise, I traverse it. If it's not been visited, I traverse it. And once I found something that has been visited before, then the entire thing gets pushed in. Okay, that's merge. Entire thing gets merged in. This has been visited before. Okay, it has visited before. How do I know which root it is? Okay, let's read. DFS merged account dot push back neighbor JSON email is this equals this, which means not find. If the neighbor is not in visited, then we DFS this neighbor. What if it is in? Then we stop, right? If it is in it, then we stop. This is building adjacency list. The first email, that pushback email, and adjacency email, the pushback. Oh, everybody is connecting to everybody else. You see that? Email dot pushback. Yeah, it's yeah, okay, that makes sense. That makes sense. Yeah, it says JSON's list. It's double, right? It's double. And then if it's been visited, right? If it's been visited, then we can go to that visited node, and that node will point to which one is it linked to. Traverse all the accounts to store components. Okay. For each account, I have a name, the first email. If the first mail is not found, if email is visited, then it's part of a different component has performed DFS only if email is not visited yet. If email is visited, if the email is visited, then you say we have already done that. If email is not visited, vector string merged account, adding account name at a 0th index. Pushback account name and then DFS merged account first email. Merged account is the actual account. We're going to push it back. Okay, so I want to go to DFS. DFS merged account. What is this email? That's account first email. DFS merged account and the current account's first email. It's right here. Account first email is the current account. if it's not been visited before that, so we set it up. So now we visit. Oh, because when you build up this graph, it's already connecting everybody, right? It's already connecting everybody. So it's already connecting to everybody. Not really. We are just doing the first account, right? The first account connect to everybody, and but this account already has the first email, and then if this email appears again, right, it will be pointing to the first email, and this email will be also pointing to the first email, and because it already pointed to this, and then it will point into first email. So that's how we get a connection. Now we connect. Oh, it makes sense. And there's no duplication. Each email, if it appears in two different places, then it will be connecting to the first account's first email and the second account first email. Or if it is the first email itself, right, then basically we go to the same node. We go to the same node and we'll, okay, so now all the emails that belong to the same person, oh, then we just do DFS. Yeah, then we just DFS, because the account first email is always the root. Then we just do DFS. And if it's been visited, that means everything has, makes sense. Makes sense. Because everything's connected. So once we do one DFS, that's sufficient. That's sufficient to put everything into the merged accounts. And all we need to do is we do this and we sort it, and then oh, nice. Oh, great. It took a while. All right, union find. How does union find go? These are null. Same representative but belongs to the same person group and hence will be stored together. And then what? 0, 0, 0, 0. Yeah. 1, 1, 1, 0. We find it and we union them together. Yeah, and they're unioned. So I guess it'll be similar implementation, right? So DSU, blah blah, for account. Email is for email account name. If email group, is equal to this, email group equals I. Else, we're gonna union I and email group. That's the same as this, right? Same as this. We're just saying if it's not in there, then we'll email I. Otherwise, we'll union the two. Oh, this makes it easier because if it's already in there, we don't have to hash map it again. Makes sense. So basically saying if it's in hash map, we simply union the two. If it's not, that's okay. If it's not, we simply just say this one equal to I. Even though I and this one must be union, but we're already union, so that's fine. So we don't have to do this. Right, so this is the union part. And then we just need to do this. Yeah, it still pass. Right, it still pass. And then we need to get it out. Group equals the second. Group dot pushback email. Sort the components. Now in this case, we did put every email in it. Hold on. We probably don't need a union. We simply go through everything, right? We find a parent, and hold on. All the unique emails is already in the hash map, right? So what? So for each one, hold on. For each one, I go to the email group. What is email group? Email group is just the same, right? Email group is a string and an integer. So we can go to the email group, go to every email group instead of go through accounts. We go through email group. So we grab the email, we grab the I, we look for, oh wow, yes, oh my goodness. What have I been doing? So we can go through for email and index in hashmap.items, right? And for each email, I can get a parent will be dsu.find index. Now I got a parent, and we do have to have a res equals this, right, for this in accounts. And then we simply say res parent 0 is equal to accounts parent 0 and res parent 1 dot append email. That's it. So we fill in this, and we can return. So we'll return name and emails, res if name, and we do emails. Oh, it's taking more time, taking longer, but this is easier to handle. I mean, we can even say if res are 0, right, then we assign. If not, right, then we assign. So this is a cleanup. So original runtime 352. So this O mn log mn and original 352 milliseconds, or a 21% ranking. And then we have an update. Update much easier way, right? So we can say maybe we can do better. What if I set this as this? And what if I use default dict for this? Default dict. default dict. Yeah, I think this is just, it's not gonna make any difference, right? Default dict lambda, we're gonna have this. And then we simply say in res.items. Oh. What happened? Res par 0, res par 1 dot append. Oh, actually dot values. My bad. It feels even slower, and I don't like it. I don't like it. Alright, we go back to this. Update. The official solution offers a less convoluted way to implement the algo with union find. Let's see how fast this one runs. Good question. I don't know. I think it's much cleaner than the previous attempt. All right, DSU, we hash map, go through every single thing. And we do this, the result, blah, 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 blah. And we sort it. Let's try. Maybe it's the same, who knows? It's not the same. Look at this. It's much simpler because, yeah, well, the major difference is doing away, right? Doing away with set union. Since we already placed all unique emails in hashmap, we can iterate, right? We can iterate the hashmap to obtain emails instead of iterating accounts. The latter requires set union, whereas the former does not. Right? And by doing so, since we do not have to use set union when constructing the result, the runtime is reduced to around 196 milliseconds, or we get 86% ranking. So yeah, we already have everything in hashmap, right? We already have everything in hashmap. Well, now let's try the second this is a very good solution. This is a DFS solution from the official solution. Build a DAG. It's actually not DAG. Build an acyclic graph for each email address, right? If two email for each account, arbitrarily, right? When arbitrarily choose the first email as the root node and connect everyone, connect the rest email addresses to the root. Now the beauty of this is the beauty of this is that if a new account has an email address, right, shared with the previous account, the process of constructing the graph guarantees that the previous account's email address graph will be connected to the new account's email address graph. And this process also eliminates duplicates, right? Then, to obtain the result, we simply DFS each email address graph, right? Each email address graph. Very good solution, very good solution. So first one, we need to say graph, right? Okay, say default dict of list. We do need default dict from collections, import default dict, right? And then to create graph for they're just gonna be email connecting to each other. So we're just gonna say for ACC in accounts, right? And for email in accounts, accounts what? Accounts 1, right? And oh, I need a root email equals account equals ACC 1. Okay, 0, 1, yeah. So this actually ACC 2 to the end. What if there's only one? That is just a root by itself. What if we have a 1? And it's not in it, right? If it's a 1, then it's not connecting to anybody, which is fine. So we're going to say for email in this, we say graph, right? Root email will equal to email. And no, not equal to, come on, dot append email and graph email, because it's not a DAG, it's a connected graph. So after we build, then we're gonna def DFS. Right. What do we have? We have node, which is going to be str, and we need to say visited. We can do visited here. So visited equals a set, right? And then we have a node. We have merged. It'll be a list of str. We don't have to return anything. So node, right? We're gonna go to a node, and we say if node in visited return, right? Because we already visited it, we don't have to go that path anymore. If not, then we say merge.append node and for neighbor in graph node DFS node and merged, right? That's it. That's the DFS. And how? Oh, and also if this and then visited dot add node. Okay, so now we're gonna grab. So res equals this, right? And then what? Then we say for account in accounts, right? So name equals ACC0 and root email equals to ACC1, right? And basically we're going to check if root email has been visited. We say if root email not in visited, right? If it's not in visited, then what? If it's not in visited, then I need to go DFS, right? If not in, and then we can say DFS merged equals this, DFS root email and merge, right? So this one, well, blah, 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 gets everything. Once it gets everything and come out, we can say res.append, right? Name and sorted merged, and we return res. Try this. Nope, it's not correct. Why? Where did we go wrong on this? Res is John, blah, and blah. Oh, everybody is only one. How? How come everybody just one? I want to have Johnny Bravo, John Smith. What happened to the other email address? Merge, I did append, right? For every node I append, let's do this, and then for each neighbor, I DFS. Oh, neighbor. Uh-oh, still not right. But yeah, we do have to DFS neighbor and merged. Okay, res John is this, this, and this. John this, Mary this. Oh, deconstruct. There you go. This one shall be right. Yep. Very good solution. Very good solution. Which is, I think this is the required. I should say required. This should be the ideal one because you don't have to write union find. Yeah, this is the ideal one. This is also mn log mn. We hit exact same runtime, 196. Very good. Graph. Graph. Graph is the way to go. Yeah. I want to add one point. If a node has been visited, that means all the email addresses of the same account has been visited already. Has been counted for, right? Counted for already. Good. All right. Well, it took us a long time. That's a good question. Very good problem. All right, that will be it for today. I'll see you guys tomorrow. Adios.